This is a production of Cornell University.
So I'm Terry Bates. I am the director of the Cornell Lake Erie Research and Extension Lab in Western New York. So we are about as far in the Western Empire of Cornell as you can get and still be in New York. And I do have a map that I'll show you where we're from. So today I'm going to talk about what we call the Efficient Vineyard Project. That building there, that is the Cornell Lake Erie Research and Extension Lab. Cornell has actually been in Western New York working with the ag industries, especially the fruit production and especially grape production in Western New York for about 110 years now. There's been several different labs in that Western New York area. The most recent one was in Fredonia, New York. We were there from about the mid-50s until 2009 when we built the new building. Somebody asked, how did you get the money to do that? And that was from both the industry and primarily from Senator Young. So she was in our district and head of the Senate Ag Committee, and it was a long time desire for the industry to have a new lab facility dedicated for research, and Penn State as well. There's the Lake Erie Regional Grape Program. The extension program is a two-state, two-university cooperative effort, which is one of the only ones that's out there. And some of the people that are in this photo, so I'd like to acknowledge the people that I work with at Clairol. So I will say Clairol, Cornell Lake Erie Research and Extension Lab. It's Clairol, not the hair care product. And so there's a mix of people here. So some of them work for the Lake Erie Regional Grape Program Extension Team, headed by Tim Weigel, who's IPM Grape, New York State Grape IPM specialist. There's also Cornell Agritech employees there that help us run the farm. And then there are other scientists that are actually employed through the USDA funded SCRI project, which we now call the Efficient Vineyard Project. Okay, so what is the Efficient Vineyard Project all about? I'm going to read this sentence, and I'm going to show you a couple slides and read the sentence again, and hopefully it'll make more sense to you. So generally today I'll be talking about precision ag technologies that we use in the grape industry. So in a broad sense, talking about precision ag, but in a very specific sense, trying to answer some of the questions for our juice grape industry in Western New York. So the goal of the project is to develop multiple sensing and automation solutions for measuring vineyard soil, canopy, and crop, and I'll talk about that, and reconstitute those for high-resolution spatial crop load management. Now, I'll try to explain very specifically what we're trying to get at in terms of crop load and how that impacts our grape industry. Okay, so again, I'm from Western New York. Here's Buffalo, here's Erie, Pennsylvania. And this strip of purple that you see are all the grape vineyards that are in Western New York. So majority of the grapes that are grown in New York are in that belt. So we talk a lot about the Finger Lakes, since you're so close to this region, Long Island, Lake Champlain region, different grape growing areas in Western New York. But in Western New York, in Western New York, we have this lake plain right up against Lake Erie. So we're influenced by the lake effect that we get from Lake Erie. It moderates our temperature in the region, and that's why we can grow tender fruit production, and grapes being one of them. As that expanded out to all of the Great Lakes, so we have a primary influence of Lake Erie on our grape growing region, but really, and this is something that Stan Howell from Michigan State used to tell me, is that we have a broader influence of all the Great Lakes. So as those cold air masses come down from Canada, it crosses all that water, that air gets conditioned, and that's why we can grow tender fruit. So it doesn't get that cold in the winter. We have about 180 frost-free days in the region. And then there was that increase in elevation. We call that the Allegheny Plateau, the escarpment. You know, the guys on the weather channels call it the Chautauqua Ridge, because Chautauqua County. This is Chautauqua County, the Chautauqua Ridge, that rise in elevation. So when you talk about lake effect snow, we get all the lake effect snow. I mean, it's not uncommon for our region down on the lake plain to get over 100 inches of snow a year. If you go up that hill, they get about 200 inches of snow. So again, just shows you that lake influence that we have in the area. Okay, the Concorde industry. So one of the big reasons I actually even have a position at Cornell is for the Concorde juice grape industry in Western New York. So if you hear about Welch's, or you go to Wegmans and you buy Wegmans Concorde grape jelly, right? It's coming from us. So in New York State, and I do cheat here a little bit because this piece of the pie does include the Concorde vineyards that are in Pennsylvania as well, because it goes down closer to Erie, Pennsylvania. So a majority of the grapes grown in New York are Concorde. So you talk about all the wineries that are in the Finger Lakes and Long Island and Hudson Valley, they actually make up a small percentage of the total production of grapes. So, and they're different markets too. Concorde, we deal on an international market, right? Welch's is trying to outcompete with orange juice and apple juice, and there's that economic impact there, where most of the wineries are very successfully selling all their product out the front door. So Concorde is very big, but it has very low profit margins. So if you look at the price paid for Concorde compared to other wine grape varieties in the state, we're bottom dollar, right? About $200 a ton, where Riesling might be getting $1,000 or more. So our growers have low profit margins, and we have become increasingly mechanized. And so here's my specific problem that we're going to try to answer with general precision agriculture. You have Concorde growers, they grow a lot of grapes. We can't just say, oh, Concorde's not making any money, we're going to start growing Traminette, right? If one Concorde grower with 200 acres planted all the Traminette, we've just flooded the Traminette market for the rest of the country. So we're kind of stuck with Concorde as an industry. And we're getting rock bottom dollar. So for them to make a profit, they have to become more efficient. We're getting more mechanized. So the concept that they have adopted in our industry is that we leave more fruiting buds than the vines can handle, right? I want to set a very high crop potential, because the way I want to make money is to have high crops. I try to set that high crop potential by leaving more fruiting buds than I need, and then I get past frost. So all those shoots come out, those shoots have clusters on them. If we get frost, that reduces the crop size. So it's a risk management strategy against Mother Nature. I leave more fruiting buds than I need, and if I get past the threat of spring frost, I can assess, do I want all those fruiting shoots out there or not? I can use mechanical shoot thinning. This is a mechanical mechanical pruner for grapevines. So I would say over 50% of our vineyards now at least do some kind of mechanical pre-pruning with a hand follow-up. Again, leave more buds than we need. Then we can assess how many fruiting shoots we have. We want to reduce those throughout the vineyard. Shoot positioning is a canopy management process we use. And then also we use a mechanical grape harvester to thin fruit in the middle of the season to try to match the crop with the growing season. And then we also use that, again, that mechanical harvester during harvest time to pick the fruit. And what we're doing, uniform management and non-uniform systems. So we're using all these machines uniformly across the vineyard, right? I take my mechanical pruner or my mechanical shoot thinner, and I just set the machine up to do one thing, and the grower drives up and down. And what we're doing with the precision ag is use spatial data to talk to these machines and make the machines either speed up or slow down as it's going through the vineyard to reach our crop load balance. Okay, so what do I need by crop load? It's a model based on 100 years of research that was mostly labor intensive. So we talk about crop load as a Rivaz index. So something very specific to us, crop mass to pruning mass ratio. And what do we mean by pruning mass? So in the winter, so one of a very labor intensive, but fairly accurate way of measuring how much vegetation the plant grew the year before and what its cropping potential is for the next year is to measure that through pruning weight. Because pruning weight is directly related to leaf area. So getting down to a horticulture background, soil, water and nutrient availability and the ability of that plant to pick up water and nutrients will impart vigor on the vine, right? So how much light interception per unit land area we're getting translates to productivity, and we actually measure that as pruning weight. Why don't we measure leaf area directly? We should. We don't. It's difficult to do. It's easier to do it through pruning weight. Crop weight is also something that is crop estimation and trying to get total crop weight is going to be at the end of the year. Also pretty difficult. We're trying to answer that with sensors. So when I say in that sentence, I want to measure spatially soil, pruning weight, and crop weight characteristics spatially throughout the vineyard, I'm putting all of those things into my crop load model. And we have a crop load model. I'm not going to probably talk for 3 sessions about this, but let me summarize by saying an overcropped vine is bad, an undercropped vine is bad, and a balanced vine is good. And viticulturists across the world talk about vine balance or vineyard balance. All it really is saying is, I want to match my crop size with the amount of leaf area I have out there and with my growing season. And we really have this down with Concorde. Again, I leave more crop than I need. At about 30 days after bloom, I'm assessing what my season is and what my crop size is, and I'm adjusting that crop to match this crop load ratio. And we tend to, again, overcrop our vines. We leave way too much fruit, and then we try to dial it back. So we're playing up here in the overcrop situation, and we try to bring them into balance with our machines. Okay, so to develop multiple sensing automation solutions for soil, canopy, and crop, and then reconstitute those with our machines to do variable rate applications to hit our crop load balance within a vineyard. Okay, so we have a viticulturist, you know, 3 guys walk into a bar, a viticulturist, a robotics engineer, and a precision ag specialist. And they all start talking about different things, which they're really talking about the same thing. So one of the things about this large SCRI, USDA funded project we had is it's multidisciplinary, and you're trying to get people in the same room talking the same language. And we come up with this measure, model, manage, or sense, plan, act, data, information, decisions, right? So each one of these guys is talking about something a little bit different, but really talking the same language. We want to measure soil, canopy, and crop. We want to model what our crop load is, and then we want to manage that through mechanization. So we break the project down into measure. So again, soil, canopy, and crop sensors, and validation of those sensors. You're going to hear me say validation a lot. If I take an NDVI sensor, which we use to try to get an assessment of canopy growth and light interception, that NDVI sensor is just giving me an electric signal, right? It's giving me, you know, this colorful heat map that just, I don't know what 0.7 NDVI really translate to viticulturally. So we go out and we do stratified manual samples in the vineyard against our sensor measurements to translate that NDVI signal into a pruning weight map. And then now that means something to me as a grower. In terms of modeling, so multi-data layer processing. So there's really, I look at modeling in 2 ways. One is, how do we make the most out of the spatial data, right? There's a lot of noise in the spatial data. There's a lot of natural variation from vine to vine in the vineyard. We're trying to pull out what the underlying growth pattern is in that vineyard. So there are ways to process that spatial data to try to pull that information out. And then, as I've explained, we're trying to also model crop load. So how does soil, canopy, and crop work together for crop load balance in the vineyard? And then manage. Again, software, hardware, you know, we're trying to take spatial data through a computer and control the mechanism on a machine. So that takes some engineering. And then variable rate applications. So as we apply those variable rates, how is it impacting our growth and productivity in the vineyard? Okay, for soil, we use what we call a dual EM. It's a EM38. You guys are all soil scientists. You guys know what I'm talking about? Because I don't really understand it that well. It uses electromagnetic induction to give you, this is a dual EM. It oscillates back and forth to give us a shallow and a deep reading, right? So we hook this sensor on a sled, drive it through the vineyard, and we get a map. It measures electrical conductivity and magnetic susceptibility at 2 depths. And does that really mean, again, this is a sensor measurement, it's an electric signal. Anything that conducts electricity in the soil is gonna, you know, change the way that sensor is giving me data. What I'm really interested in as a viticulturist is that it gives me a map, right? It gives me a heat map of that vineyard. And now I can break that vineyard up into zones and I can stratify my soil samples against it, right? Our guys do soil sampling, but they do it randomly, right? I'm gonna go out to block H and I'm gonna take 2 soil samples. There's no direction in where they're taking that soil sample at the moment. By using one of these maps, they can be more directed. And then, you know, if the blue area makes up 40% of the vineyard and say the orange area makes up 60%, now they can start having a weighted average about what their soil is like in that vineyard. And mostly, we look at shallow electrical conductivity because that has, it's usually the clay, the type of clay, and the amount of clay that's in that shallow profile that's having the most influence on our Concorde vineyards. Why is that? Well, from a horticulture standpoint, own-rooted Concorde tend to be a shallow-rooted So in the world of viticulture, you can use a rootstock, and rootstocks have different root growth habits. There are some rootstocks that go straight down. There are ones that spread. Concorde, own-rooted, tends to spread, so that makes a lot of sense to me that the amount of clay content and organic matter and soil pH in the upper profile of the soil is going to have an influence on our vine growth and production. But a map like this starts directing me to take samples and be able to validate what's going on in the vineyard. So, and for the most part, you know, you get a county soil map, and when you use the soil sensor, you're getting a little bit more detailed map to work off of. And in our region, so I showed that map, Lake Erie and the escarpment, everything's in the lake plain. And those actually from the lake to the escarpment is a series of ancient beach ridges. So like every 30 feet, the soil type changes. And we can start picking that up with that soil sensor, and it has an impact on our management. For our canopy, we use NDVI, so Normalized Difference Vegetative Index, and it's really using red and near infrared wavebands on a sensor. So you can get NDVI from a drone, you can get it from an airplane, you can get it from a satellite. We use, pretty much when we started the project, we're like, what's cheap and easy? So we can buy these NDVI sensors. There used to be one called a Green Seeker that was part of NTech Technologies. Now I think it's bought out by Trimble. We use Crop Circle. This Crop Circle sensor has 3 wavebands. So it's sending out white light, it's hitting the leaves are reflecting the light back, and we're sensing with near infrared, red, and red edge. And we can use those 3 wavebands to come up with different plant indices. What I'm really looking for from my standpoint is there a leaf there or not? I think the next video will help explain that. So NDVI is just a way to measure, are there leaves there, and what's the health of the leaf? We put it up against the canopy because I want to know where the vines are growing very strong and where the vines are growing very weak, and how that changes throughout the vineyard. So this is the old Green Seeker. We used to go really slow. Here's the Crop Circle sensors that we're using now. So the 3 wave bands go through there. That's a Gallo vineyard. That's a table grape vineyard. So this is a national project. We're working in vineyards both here in New York and California. That's a Merlot vineyard in California. Okay, here's a vineyard in Michigan. So this gives you a good idea where the canopy was very sparse. We were going to get low NDVI values. Now here where it's very thick, we're going to get higher NDVI values. And we get maps like this where it's showing me where the vines are pretty weak and where the vines are pretty strong. So in terms of Concorde, horticulture again, high wire cordon, the shoots come out and then they droop down, which it might be different than a lot of the vineyards you'll see around here. With like Riesling would be a low wire cordon with an upward growth habit, and things are put up into catch wires, so you have a vertical shoot position system. So we work them both. But here in Concorde, if early in the season, this makes a lot of sense. We use one sensor. We used to use an array of sensors that didn't really help us out. We use one sensor here, and as that vine grows throughout the season, we actually drop the sensor. So I know if one vine is growing very, very strong, right? This is the sensor will saturate. If I still have weak vines in the middle of the season, I'm getting lower signatures. So again, really we're just seeing, are there leaves there or not? And it has a little bit to do with the health of the leaf, but we don't really address that too much at this point, although that's on the horizon. Okay, validate. So again, we take a heat map, we take so we'll stratify samples based on that map. This is a guy collecting pruning weights. So again, we either through machine or by hand, you prune a vineyard, you actually pick up the sticks and you weigh them. It's a very labor intensive process. Nobody wants to do it in the middle of February. One of the reasons I started this project is I said I never wanted to take pruning weights ever again. And now I take more pruning weights than ever before. So ironic. We look for those relationships. What is the relationship between vine size in terms of pruning weight and our NDVI signature in the vineyard? So I can translate this color map that's an NDVI map into an actual pruning weight map, and I use that in my pruning weight or my crop load formula. And we do the same thing with growers, right? So we actually have a loaner sensor program right now. So as growers are out spraying their vineyards or mowing their vineyards or applying fertilizer, they can put one of these sensors on their tractor, collect data for us, They come back to us, we process the data, we'll give them the map, we'll define where the transects are, that they can take their validation measurements, and then so every vineyard can get their own like internal standard for what their NDVI to pruning weight relationship is. So we're turning a pretty picture, this pretty picture of NDVI actual into a pruning weight map. And when you talk to growers, you know, a 1 pound vine, 2 pound vine, 3 pound vine means something to them more than an NDVI value. Crop estimation. So the industry is very hot on this topic of crop estimation. I want to know mid-season, either destructively or non-destructively, what my harvest weight is going to be. They want to know within 5%. And if you're dealing with a 5-acre vineyard, yeah, you probably do that. When you're dealing with 30,000 acres, it's a really difficult question to ask because there's so much variation out there. Soil management, vine growth are all impacting these. Traditionally, a viticulturist throughout the season will measure what we call yield components. They'll do it manually. Sampling, typically random. Can we make that better by stratifying our samples? We think so. But they will measure shoot counts because all these shoots have clusters on them. So the number of shoots will relate to what your total crop weight's going to be. Clusters per shoot or cluster count, berry count. So a Concorde flower cluster may have 100 florets on them, and about 30 of those will set. Well, some years it's 25%, some years that's 35%, right? So that'll change. So knowing what the berry count per cluster is, and then berry size. So these yield components, shoots per vine, clusters per shoot, berries per cluster, and berry size all impact what our final crop estimate is going to be. We are working with engineers at Carnegie Mellon who have developed this image analysis system. So they take this red machine, it's a stereo image, we call it the shiny red bike. It goes through the vineyard and it takes pictures of the vine. So at different times of the season, when it's early season shoots or mid-season cluster counts or berry size, it stitches those images together and then they use algorithms to count what's in those images. And so far, it works very well at counting what it can see. It doesn't do a very good job counting what it can't see. So if you're trying to count berries on a cluster, if those clusters are exposed, like in a vertical shoot position system where the leaves are pulled and the clusters are hanging out there, it's very accurate at counting berries. But then you also have berries hiding other berries. So they deal with this occlusion factor or visibility factor. So they're trying to measure these yield components, identifying what some of their occlusion factors are, and then they try to make a crop estimate based on that. Okay, here's a video of the thing in action. We will use it during the dormant season. They're trying to develop algorithms to count buds, so dormant buds, and then shoots, and they work in table grapes looking at color development. So this thing goes down, it flashes. We use stuff like leaf blowers to try to get the leaves out of the way so we can take pictures of the fruit. This is a Merlot vineyard in California. So again, this is what it's taking a picture of. This is what it is going through its algorithms to count the fruit that's there. And then it's developing a spatial map of berry count across that vineyard. And then we validate that with yield monitors. I'll talk about that in a second. So here's their CMU imaging of berry count in that vineyard. And then the harvest yield monitor this is what we get off of the yield monitor. And we try to look at the relationship between those two and see how close they match. Yield monitors, okay. So it's all coming together here. So we're evaluating 2 yield monitors on a harvester, and this really helps with, we have a crop estimation in the middle of the season and what is our final crop weight at the end of the season. So there's a yield monitor. One was developed in Australia, and then there's another one that was developed by a company called Oxbow. It sits right here, the one from Australia, on the cross conveyor. So, if you've ever seen a grape harvester work, grape harvester goes over one row, it shakes the vines, the fruit falls off, it goes over this conveyor belt into a chase tractor, into bins, and those bins get put on a trailer, and then they go to the processing plant. So this yield monitor has a false waveframe, and as the fruit goes over the belt, it's recording a weight, and we can map that. Everything's hooked up with GPS. We also have another one called an Oxbow type. Oxbow is a company that makes like pea harvesters and grape harvesters, and they have an impact plate one. So many of you are probably familiar with grain harvesters. They use an impact plate as the grain's coming off, it's hitting a plate, and then they translate that into a yield signal. We're doing the same thing with grapes. Again, validation. So whether it's the impact plate or the false wave frame, we're relating the yield that's coming off of the sensor to actual either bucket weights or bin weights or actual truck weights that go into the plant. We're relating those to what the yield monitor says, and we're getting nice relationships, so we can use that. Something that's hot off the press, so this image was actually made earlier this week during our harvest this year, is juice-soluble solids mapping. So grape growers get paid for their grapes based on yield and sugar content. Juice-soluble solids, something we call bricks. We measure refractive index of the juice, and we call that bricks. And so they get paid on yield and bricks, right? And there's a minimum bricks level. If you drop below that minimum bricks, your load gets rejected, or you go into a low solids program, and you get paid a lot less for their grapes. So growers are really interested to know what their yield and their sugar content is as they're harvesting, because if they go into a field and the bricks are too low, they have to go to another field and pick the fruit that's ripe, or they do something Welch's doesn't want to hear about called field blending. Is they will put unripe fruit in a bin, and then they'll go to a field that's ripe and they'll put more sweet stuff on top and try to get that into the plant. We're trying to eliminate field blending. So if we can either measure juice soluble solids on the fly or use our crop load models to predict, this field's going to ripen last, this one's going to ripen earlier. That's, that directs the grower to be able to go out and pick the fruit when they need to. So, okay, so there are inline refractometers that you can purchase, and they use them in factories, and you can measure the bricks. That's not like the development. What is my crew has been working on, and we're going to try to protect the intellectual property, is how to get juice to the refractometer. So grapes are falling off of the belt, and it's very difficult to measure the bricks of all that. You're getting non-soluble solids in there as well, so skins and leaves. So guys that I've worked with, they have developed a processing unit that mounts onto a harvester that actually samples a portion of the fruit that's falling off of the belt, and it puts it through a mechanism that sends juice to the refractometer. Refractometer reads it, and actually the juice goes back on the belt to be harvested. And these are the first maps that are coming off of that system. So we're pretty happy with that. Okay, I'm gonna keep moving. Modeling. So that's our measurement, right? We measure soil, canopy, crop. We have these different sensors, dual EM, NDVI, destructive and non-destructive yield monitoring with the CMU imaging system. We also have a destructive system that we use that, we actually go out and clean pick fruit in the middle of the season to try to estimate what's in. So there's different ways of doing that. And now we also measure yield and bricks monitoring. So all those sensors are working together. Now we're talking about modeling of the spatial data. So again, when I first started doing this, I did it probably like most people who are getting into this business is you have 40,000 data points in a field. You project those through ArcGIS or some other spatial program, and you try to do some data smoothing, and you get a picture and it can be very useful. But there is information in that spatial data that is difficult to get out. And so we use both global variogram modeling and local variogram modeling to make these images. And again, what a variogram tells us is how much of the variation in the vineyard is random, right? So I have big and small vines over here, but most of them are big. I have big and small vines over here, but most of them are small. So there's a lot of this randomness that's going on. And a global variogram of a field will tell me, 50% of your variation is this random, I use the word crap? It's random crap, and it's just like making noise in my data. And then 50% of the variation is spatially structured. It's based on, my soil type is more clay over here, it's more gravel over here. And that's what I want to manage against. So I want to be able to capture that. And that's what this kind of modeling does for us. So as this smoothing technique, I guess is the best way to say it, it's actually looking at every data point, and it's looking at the neighbors of data points around each one to say, as I get farther and farther away, how are those points influencing this point? And it smooths that data, and it does it in a way in which we can extract the pattern out of the vineyard. And then we project. So this smoothing process is done on a common grid. So we just happen to select a grid size that is equal to our vine density. So it's basically every grid point equates to a vine. And I know now that I project everything onto a common grid, I can look at the soil map, the canopy map, and the crop map, and I can mine through that data and say, at this point in the vineyard, I'm standing here, right? I have this kind of soil, it's imparting this kind of vine growth, and I should probably be able to hang this kind of crop here to get it ripe in an average growing season. And I'm using that now to manage my vineyard. So then we look at all these data. So we're collecting all this data, right? So one of the comments that the industry growers will say, oh, I'm in California and I pay someone to do a flyover of my vineyard of NDVI and I have all these maps sitting on my desk. I have no idea what to do with them, right? That's a big issue with the industry is I have data, I don't know what to do with it. So what we do, again, since everything's projected onto a common grid, I can mine through that data. I can look for correlations between the soil and the canopy and the canopy and the crop. And there are some images where I'm like, yeah, it's garbage, right? Like the deep magnetic susceptibility is just some big streaky map and it doesn't mean anything to me. Where say a shallow EC, a mid-season NDVI, and my yield map all have some kind of correlation that's going on. So we talk about at some point in the process of all this, we need to have the grower's input, right? You need it. The grower has, based on their economics, based on what they're growing and for what market, they have their own idea what they want to do with the vineyard. So at some point, they need to come into the process, and this is where they would come in to say, yep, I know there's a low spot in my vineyard, and I know that's affecting my productivity. So yeah, leave that layer in, and then we find the layers that we want. We do what we call a k-means cluster analysis. So it's taking the data from, say, these 4 layers, and it's creating zones. And it is trying to mean separate those zones as much as possible and reduce the variation within those zones as much. So you have discrete zones within the vineyard that hopefully make sense viticulturally. And you can also click on the red and it'll tell you, oh, you have this kind of soil, this kind of canopy, and this kind of crop. How do you want to manage it? Same thing with the red or the green and the blue zones. Okay, so we measure with all our sensors. We model that data, doing the spatial data processing, coming up with our management classifications. And now we have to manage it. So I'll give you, best way to try to describe this is through an example. So here's a grower, it's a Concorde vineyard. It has a small, a medium, and high vine growth area, right? And we do our crop estimate in middle of the season, and we know that the red zone has about 8 tons per acre. But we know those vines are really small, and we're like, no, you cannot ripen 8 tons per acre on that part of the vineyard. Then the blue zone are big, healthy vines. They have more water, more nutrients. They can ripen a larger crop, and they're hanging almost 12 tons per acre. And we're like, you know what? Given the growing season, you probably can ripen that much. So I want to take off more fruit here, actually, to try to get the small vines in balance. And the big ones, I'll take off a little bit, but I'm going to leave more crop because it's able to ripen that crop. And we do that with a harvester machine. So this harvester, middle of the season, it is going to, just like at harvest where it shakes the vines, but it's going to shake them more gently. And it'll take off, say I want to take off 2 tons per acre here, it'll take it off. Maybe I want to take off 1 ton per acre here. It'll slow down the beater speed and take off less fruit. So we have our spatial data, goes into our map. The map talks to this computer. We use an ag leader system, Trimble and Raven, Chevy, Ford, people have their favorites. We use ag leader just because that's the system we work with. So it goes into their software. So we actually trick this system. This is really meant for liquid fertilizer application. So it's all about flow rates. So we actually have to tell in the dark blue zone, I want this flow rate, and in the light blue zone, I want a different flow rate. And instead of going to the liquid dispense of fertilizer, we send that signal to what we call a PWM valve, a pulse width modulation. If you ag engineers are out there, you know what I'm talking about. It's basically a hydraulic valve that chirps. The faster it chirps, the more hydraulic fluid that goes through, and the faster the machine works, and vice versa as it goes slower. So the map talks to the PWM valve, and then the harvester just goes. So at crop estimation time, we want to take off all the fruit. So we drive very slow and we shake the vines really hard and we harvest that fruit, we collect it and weigh it. We're using that to do our crop estimate. That's how I got to I have 8 tons per acre here and I have 12 tons per acre somewhere else. And then when I want to just shake off a little bit in the different zones, this is in the throat of a harvester. And so now we're driving much faster, somewhere between 5 and 6 miles per hour through a vineyard, but shaking the vines very gently just to get a portion of the fruit to fall off. And then we put that into our crop load model. Remember, so going way back to the beginning of the talk, fruit weight to pruning weight ratio, we're using our spatial data validated against those kind of measurements to come up with our harvest yield map. So our crop weight, our pruning weight map based on NDVI. We actually do the math between those two to come up with our crop load or Revaz index. And in these strips here are our controls where we didn't do any thinning. You can pick those out. So a red color would be overcropped. And by doing variable rate thinning within that vineyard, we made it more uniform. So pre-thinning, we had vines in the red, green, and blue zones that were all overcropped. So here's my Revaz index. I'm trying to, where I want to be, balanced vines are about 15. So we got stuff that's way up in the 30, 35. So these are way overcropped. But we need to bring the reds down more than the blues, and that's what we did. So after variable rate thinning, we've shifted these population curves down. So that's what I'm really trying to do. The ultimate goal is I want to shift the population of those vines where I want them, and I want to make them more narrow, right? I want to make them more uniform because that's going to have a lot of commercial benefit for our grower that A, they're balanced, and B, they're not as variable. So my fruit's going to be more uniform coming into the harvest. Okay, just a couple benefits that we've seen so far. You know, I knew I had a problem. I didn't know it was that big. So that's like the first thing we're getting benefits out of, just a single data layer, whether that's soil or canopy or crop. It's giving growers an idea of, wow, I had no idea that I had that much variation in my vineyard. I didn't know I was losing so much money in this one section because my crop was too low or my vines were too weak and I need to do something about it. Improved crop estimation. So there's a question of crop estimation on an individual farm versus crop estimation for an industry. I think they're two totally different questions. I think we're addressing the first one. How do I get crop estimate in my particular farm? The goal is to be within 5%. We're using spatial data to stratify our mid-season crop estimation samples, and that's putting us somewhere in the 5 to 10% accuracy range, looking in commercial vineyards. If we use random sampling, we're off anywhere from 10 to 23%. And probably somewhere around 25 to 30% is what the industry would say that they're off every year, about 30% of what they thought they were going to be at. So we think the stratified sampling is going to give benefits to our crop estimation to get with the 5% range. Preventing just one rejected load pays for the technology. So in this case, we're doing on-the-fly yield and bricks monitoring. Again, if I'm a grower and I have a semi-load of Concorde grapes that's worth $6,000 and it goes to the plant and it gets rejected or it goes into a low solids program, I've just lost a lot of money out of my operation. So if I'm picking and I can see what's going on, be able to visualize the fruit ripeness in the field, then I can prevent that from happening and the technology to pay for itself. And this is the quote I love the best: making a decision in May that saved my ass in October. So this was actually just said to me last week. So one of the growers we're working with, we were doing the variable rate shoot thinning work in his vineyard. So again, left way more buds than he needed. We went out, did early season NDVI, related that to shoot count. So then, and he had an idea, oh, I want to leave about 120 shoots in this vineyard, maybe less on these vines, more on this vines. We did a variable rate shoot thinning trial in May. So he got past that threat of spring frost, could assess what his crop's going to be, do variable rate crop adjustment at that time. And he did it. There's one field where we did the experiment in, there was another field where he didn't do the experiment in, and that fruit was just not getting ripe. We've had a lot of rain this fall. So the sugar went up and it's kind of hung out there. And he went to pick that field, couldn't get it ripe, went over to the field where we did the variable rate shoot thinning and was able to pick that load and get it in. So he said that, you know, at least on that particular day, the technology saved it. Ooh, and I think that's it. And I'm under time. So, so thank you for listening. And I can take questions.
Is there any opportunity for scaling on the lines?
Yes. So Julie Tarara is, she was a researcher out of Washington State and then with USDA, did develop a strain gauge on for the wire. And so the answer is yes. And there's some published work on that. I don't know if Justine, you have anything to add to it. Just
it was just never commercialized,
yeah.
To my knowledge. Although it's a good solid paper, so there's a
yeah. So again, like with a lot of our sensors, you have the strain gauge on there, and there's a lot of noise, and then you use the software to kind of eliminate that noise, and then throughout a season, you can feel how that, how there's more tension on that wire and less, and you have to separate out how much of that weight is canopy and how much of it is crop. And, yeah. Yes.
Can you talk a bit about variation climate, year-to-year variation, how that impacts how you manage it?
Yes. So that's all part of our kind of our crop load decision. So we've been doing destructive crop estimation work for 20 years now. So the way we do it is a grower will actually take a rope that's 1% of an acre, so 48.6 feet, lay that out in the vineyard and clean pick that 1% and weigh the fruit. And based on the berry curve, roughly 30 days after bloom is 50% of final weight. So at 30 days after bloom, if they pick 4 tons per acre, they know they're going to have 8 tons per acre at harvest. Based on weather conditions, so especially the timing of bloom, we kind of have rules of thumb that we go by. It's like for every 3 days is equal to a ton. If I'm 3 days early on bloom, that's an extra ton I can ripen. If I'm a week late on bloom, that's 2 tons I probably can't ripen that I would normally ripen. As far as long-term data sets, so we have phenology dates, right? Same set of vines that we've collected bud break, bloom, veraison, harvest dates on, and we do see a trend, over the last 50 years, a trend towards earlier bud break, earlier bloom, and that should translate into more fruit that we can ripen. Falls also seem to be getting wetter. So we've had a lot of rain just in the last couple of weeks, and that'll hurt us in terms of trying to ripen that fruit as well. So I don't know if that answered your question or not. Yeah. Yes.
Yeah, I have 2 questions. First question is for the crop weight, for the berry size. Are you consider using LiDAR to get the size of the berry? I think that would be probably more precise way than just taking images.
Okay, yeah, yes and no. So yes, we started to use LiDAR very early in the project, and it was more towards canopy structure, not much with berry weight. And yes, I agree with you. There are other sensors out there that I think could help us. Carnegie Mellon is really focused on their image sensor. They can get a berry diameter. So the answer is yes, but we're not using them.
Yeah. The second question is you have this curve, you show that many times. I don't know, because it's too small, I don't know what is Y, what is X, but the curve is initially linear and then slowly gets saturated.
Yep.
How that curve is scalable across across space. Because apparently to me that curve is from some kind of calibration between the remotely sensed data set and your ground measurement, right?
So
and that should be from one field. But how stable that curve is, you just got to have entire 30,000 acres, right?
Yeah. So if you go back to 1960, there'll be a curve on pruning weight and yield, and it does the same thing. So as the vine gets bigger within its defined space, as the vine gets bigger, it produces more leaf area, and then it 100% fills that canopy space. And by making the vine even bigger or more vegetative, all you're doing is packing it with more leaves, but those leaves aren't productive because they're tucked up into the shade. So we see the same curve. We see that with our NDVI because the sensor is pointing at the canopy on the outside, and you're getting, when the canopy is not filled, it's increasing. By the time that canopy is filled, it saturates that sensor, so that curve flattens off. I think that's translatable to other vineyards. I still say the number one problem in our industry is lack of vine size, right? I would say almost all of our vineyards are dealing with the 1 to 3 pound vine, not the 3 to 5 pound vine. If you go to a winery that's on a very vigorous rootstock, and Justine knows very well about this stuff because a lot of her work is on decrease in vigor. So there are a lot of wineries that are dealing in the 3 to 5 pound vines, and they're actually trying to bring the vine size down. So I think the way to answer your question is, if you're below 100% canopy fill, I think NDVI is very good. I think if you're above 100% canopy fill, I don't think NDVI is very good. And you need other technology, whatever that is, to measure canopy density would be a good one.
Terry, I have a question about the thinning, just generally, and that is, while plants generally do have responses that allow them to adjust, let's say, flower numbers by aborting or arresting the development of some of them, or even after fruit begins to grow, if the conditions of the environment or the internal physiology of carbohydrate supply or something is not adequate, the plants do have mechanisms to abort or arrest development. And yet it seems that in your grapes, they tend to be very liberal in allowing a lot more fruit than what you would like as a grower to maintain. And you're making the adjustment with the thinning process. And that contrasts a lot with my experience in maize, where generally what we've found is that the germplasm and the genotypes that are out there tend to be too conservative relative to what growers would like, and through breeding and trying to get the plants to not abort and become barren plants under stress conditions. So can you make a comment on what is it that's different about grapes? Is it something about the female character?
No, it's not that different. We do measure the yield components, and as we increase bud number, we will increase yield, but there's like a diminishing return on that, right? As you increase bud number, the yield goes up, but the clusters per shoot average clusters per shoot will go down, average berries per cluster will go down, average berry weight will go down. We actually put all that stuff into our crop load model account for that. But really the bottom line for us is that we can overcrop a vine. Like the reduction in yield components isn't as great as you can make it. So I can leave 150 buds on a Concorde vine on an 8-foot spacing, and it could potentially produce 12 to 15 tons per acre, which we will never get ripe. If I left it there, vine size will end up going down because of carbohydrate balance. So about mid-season till final harvest. So we've done studies looking at starch accumulation in perennial structures. If you have a vine that is overcropped, the starch is going into the wood, sugar is going into the fruit late in the season, and that there's a balance there. Too much crop, you're going to get less starch into the wood, so less root growth, less vine size, less pruning weight, less productivity for the next season. So what we tend to see is you overcrop a vine because you forced it by leaving too many buds. You drive vine size down and your production goes down over years. Actually, when I started working at Cornell, there was a big issue called Miller-Rendage, and I think we finally came up that it was a carbohydrate issue. So growers started going to minimal pruning, which was they just skirted the vines. So you suddenly left, you may have a vine that you pruned to 60 buds for 20 years. So you kind of kept the crop load down. They were balanced. So there were strong vines. And then all of a sudden you left 400 buds by just hardly pruning at all. And it was a system that came out of Australia. So all of a sudden you had 13 tons per acre, 13 tons per acre, and then the next year it came back with 2 tons per acre, and then it bounced back up to 15 tons per acre. And the years that I had 2 tons per acre, all the clusters were there, but the fruit never developed. So it's similar. it's just the way we attack it now is we try to balance it, leave a little bit more crop than we need, and adjust down as necessary. Yes.
Terry, quick question regarding the thinning of the fruit. Are the grapes, the berries that are left, are they damaged by? And is that a problem, or just out of curiosity?
If you do it right, no. Again, we've been doing this for as long as I've been here. It was a system that was started with Bob Poole before I came on board. And yes, you will talk to growers, and there have been horror stories. So the harvesters we used to use, they have rods in them, and they used to have straight rods, and they used to hit the vines like this, and there was a lot of whip action at the end, and there was a lot of broken shoots, a lot of damaged berries, and people said, thinning, mechanical thinning is never going to work. And to this day, I have old growers like, you're killing my vines, never do that again. But now the harvesters, we can tighten up where the bow rods are. They're not straight rods anymore, they're bow rods, so there's no whip action. And now they're in sync. So we actually grip the vine and we just shake it a little. And again, there's a variety issue thing here. Concorde, at the end of the season, we'll have 3 gram berries. Middle of the season, when they're thinning, they're about 1.5 gram berries. Most vinifera, especially like Riesling, that's a tight cluster variety, at the end of the season will be 1.5 gram. So the berries are much smaller. So again, Concorde, loose clusters, big berries, middle of the season, it actually works fairly well for us. We have trouble with tight clustered vinifera varieties. There are other machines out there that are trying to do it, but yeah, we get a lot of damage when we start working with some of those.
Okay, well, thank you very much, sir.
Yeah, thank you.
This has been a production of Cornell University, on the web at cornell.edu.